All right, we're in section 11.3. We're going to use normal distribution. So normal distribution is, it says it's a probability distribution modeled by a bell curve, which is the bell curve right here. Um, that is symmetrical about the mean. So the normal curve is the bell curve that models the normal distribution, which we have here. So anything directly in the middle of this bell curve is the mean of whatever the data that is being represented. So anything to the right of the mean is plus either 1, 2, or 3 values of the standard deviation. Anything to the left of it is subtracted by 1, 2, or 3 um, values that lie between the, again, the standard deviation of the mean. So you have these percentages here, which means that like it's, you know, 68%, 95%, 99.7%. What this means is each, oh, sorry. So like the 68% means it lies within one standard deviation of the mean, 95% lies within two standard deviations of the mean, and the 99.7 is it lies three standard deviations to the mean. So if you were to represent this bell curve, each one of these pieces has a specific percentage. In this case, it's 34% because it's split of this 68%. Okay, this portion right here is, 13.5, because if you take 13.5 plus 34 plus 34 plus 13.5, you get 95%. Here you get 2.375%. So again, if you add it up to 2.37, 13.5, 34, 34, 13.5, and 2.35, you get the 99.7. So um, what you're going to have to do is kind of take a look at these different pieces of probability and then determine what is the percentage of it occurring uh, in this particular piece of data. So what they're asking in this example right here is they want to know what the probability of you selecting a piece of data that is going to be in between the mean, which is right here, and three three standard deviations to the mean. And that looks like it's to the right. So like here's your mean here, here's three of the standard deviations to the mean over here. So that is how we determine what these probabilities are. So what you're going to do is, since this x value lies between the mean and 3 plus the standard deviations, the probability, you're just going to take the sums of those different area values of the bell curve, and that is going to give you your percentage. So like everything else, when it comes to decimals, it comes to percentages, just write it as decimals and then convert. So what we got is, in this particular instance, it, here, I'll erase this to give you a better idea. So for this one, it's going to be here to here. So all of this lies between the mean and three times the standard deviation of that mean. So you're just going to add up those three values. So in this case, it's going to be 0.34, 0.135, and 0.0235. So when you add all those up, you get 0.4 4985, and then when you convert that to a percentage, it's going to be about 49.85%. Okay, so again here they want you to find a probability that is less than or equal to 1 minus, or it looks like it's just 1 minus the standard deviation. So if you look here, so let's, if I did some erasing here, so it says that this is going to be a value that is less than or equal to 1 minus, so values that fit that particular piece of data is going to be what, here, here, and also there. So those are all less than or equal to this value of x, whatever piece of data that you're trying to find. So that means you're going to go and say, oh, this is just going to be 0.135 plus 0.235 plus 0.0015. Add those together, you get 0.16. So the probability of you collecting a piece of data that is less than or equal to um, 1 minus 1 standard deviation is 16%. Over here, in this example, they want you to find a piece of data x that is in between 2 times the standard deviation and the mean. So it's mean minus 2 times the standard deviation and the mean. So again, if I go over here, so 2 times standard deviation is right there, mean is right there. This case is just two values. It's this right here. So it's 13 and a half and 34. So what we're going to have here is 0.135 plus 0.34. Add those together, we get 0.475. So we get 47.5% as my probability. Okay, so here, it says the math scores of a 2004 SAT exam are normally distributed with a mean of 518 and a standard deviation of 114. It says what percent of the test takers have scores between 518 and 746. So what you're going to do first is well, tells you, okay, what the mean is. So they're telling you that the mean is the 518. So I'm going to write that in right here. So 518 is the mean, and they're saying that the standard deviation is 114. So to figure out what the next value is to the right, you are just simply going to take 518 and add to the standard deviation, which is 114. So when you add those two together, you're going to get 632. And when I add, again, 114 to 632, I get 746. Add that together, I get, what, 860? And so if you go to the other side, excuse me, you're just going to subtract it to 114. So when you subtract it, you get 404. Whoops. Sorry about that. You get 404. Subtract that, you get 290. And then when you subtract that, you get 176. So again, you have your mean of 518, and then larger than the standard deviation and smaller with the standard deviation of those means. So the first question is they wanted you to find scores between 518 and 746. So if you look at here, 518 and 746 are right here. So it's going to fall into this portion of the curve, and you're going to use the same percentages. So if you look here, this was 34%, and then this was 13.5%. So all you're going to do is, okay, so this kind of says, all right, it represents two standard deviations to the right. So that's what that box tells us. So that means you're going to look at 34% and you're going to look at 13.5%, which gives you, there is a 47.5% chance of you picking something that was between 518 and 746. The second question states, what is the percentage of test takers that scored less than 404? So everything that's less than 404 is represented right there. So now, again, you're going to use those same percentages. And so this was 13 and a half. This was the 2.35. And then this was the point, what, 1.5. Let me just double check. Yeah. And then you go over here and we'll just write that in. So we got what, 13.5 plus 2.35 plus 0.15, which gives you a percentage of 16%. So 16% of math scores were below 404. Okay. So same idea here, different example. They wanted you, it says the blood cholesterol readings for a group of women are normally distributed with a mean of 172. So I'm just going to write that in right away. And then the standard deviation is 14. So that means anything to the right. So adding 14 to each of these after the mean. So it's going to be, what, 186. And it's going to be, what, 2. So what, 200? And finally, what, 214? Then to the left, you're just subtracting 117 to 14. So now I get what, 158? I get 144. And final number is 130. So what they're asking here is, so we have, it says 158, 186 is one standard deviation from the mean. So you can basically say that 68%, because 58 and 68 are right here, and that would be where this comes in. That's 34 plus 34. And then the second question here, it says readings higher than 200 are considered undesirable. What percentage of the readings are undesirable? So since it's two standard deviations, so it's going to be what, here and here is considered undesirable. With those percentages, it's going to be what, 2.35, and we're going to add it to the 0.15. So you have 2.5% of readings are considered to be undesirable readings. All right, so now we have, it says we have a standard normal distribution. So still have the bell curve. This here has, it says, is a normal distribution mean has a mean of 0 and a standard deviation of 1. So again, this is right in the middle, 1, so 1, 2, 3, -1, -2, -3. Um, what this does is it allows us to find what is called a z-score. So a z-score is a particular, they say an x value, and it's the number of standard deviation of the x lies above or below the mean. So this is how we find the z-score, which is the piece of data that you are looking for, subtracted by the mean and divided by the standard deviation. So this table right here is going to be really, really important for us to be able to discover what that z-score value um, actually is, or at least be able to find um, attach percentage to it. And I'll kind of show you what it is through the example. So again, this is something that I would recommend copying down, or at least being able to print out so you can use this in your um, findings of these problems. So in this particular instance, it says scientists conduct an aerial survey of a seal sanctuary and record the number of X seals they observed during each survey. The number of seals observed were normally distributed with a mean of 73 seals and a standard deviation of 14.1 seals. So they're asking you to find the probability that at most 50 seals were observed during a survey. So again, this is the formula. They're telling you again that this is the mean. Well, they told you the mean. The mean was 73. So this is going to be 73. Standard deviation is 14.1. And the x value that we're trying to look at is right here because we want to try to find is at most 50. So you get to plug all those values in and kind of go from there. So for this particular one, we got z score is going to be equal to 50 minus 73 all divided by 14.1. So this is going to be equal to what? Negative 23 over 14.1. So we have a z score of negative 1.6. Um, so now what we can do is we can locate where negative 1.6 is on the z-score. So if we go back, so again, remember it was negative 1.6. Over here, I'm going to find negative 1, which is right there, and I'm going to find 0.6, which is right here. So this is where it crosses. And it gives you a value of 0.0548, which means that in this particular instance, the probability of at most 50 seals are being observed would be 0.0548, or let's just say as a percentage, we'll say it's about 5.5%. Okay? And last example here, it says a survey of a group of women found that the height of a woman is normally distributed uh, with a mean height of 64.5 inches and a standard deviation of 2.54. They want to find the probability that a woman is at most 58 inches tall. So again, the mean was that 64.5. Standard deviation, they said, was 2.5, and the number in question was 58. So look at this, find the z-score first. So the z-score is going to be uh, 58 minus the 64.5, divide that by 2.5. So that's going to be equal to negative 6.5 divided by 2.5. So now I got a z-score of 0. Oh, I'm sorry, that's wrong. I got what, negative 2.6. So now I got to go find negative 2.6 on here. So negative 2 is right there. Negative 6 is right there, or 0.6 is right there. So where they meet. So it's going to be 0.0047. So I can say with the table, it's going to be 0.0047. So the probability of this is going to be what, 0.47%. If you round it into 0.5%, then that would make sense as well. And that is being able to use normal distribution. Hope this helps. Until next time.